The rover has been investigating the Yellowknife Bay area as part of an effort to pick the exact location of our first drill activity on Mars. The images being returned by Curiosity show a diverse collection of interesting features, including sedimentary rocks, pebbles, cracks, nodules, and veins. The vein features are seen as a bright white material, and we see them just about everywhere we look in Yellowknife Bay. The ChemCam instrument has found that these veins contain elevated levels of calcium sulfate, likely in the form of basanite or gypsum. Gypsum veins are also seen here on Earth and are associated with water percolating through cracks in fractured rocks. The exciting news from all of this analysis is a candidate site where Curiosity will conduct its first drilling activity. This site is located only a few meters away from the rover's current location and lies in a flat area suitable for drilling. The team hopes to drill directly into one of the veins and place the powder into the SAM and CheMin analytical instruments. These instruments will give us detailed information about the composition of the material.
We began our first drilling campaign at the site we named John Klein. John Klein is an area that has a set of flat, platy rocks that are perfect for the first use of the drill. We were able to place the arm safely and drill vertically down into the rock to collect as much sample as possible. We started by making a small divot to test the hammering mechanism in the drill. This worked perfectly, so we proceeded on to make a mini hole. Our mini drill test drilled 2 centimeters down into the rock. We compared the tailings created by the mini drill to the extensive set of test rocks that we've drilled here on Earth at JPL and determined that the materials that we see on Mars are safe to ingest into the system. After these preparations, we were all very excited to move on to the big event. We drilled 6.5 centimeters down into the rock. We used a camera on the end of the arm to take pictures. Here we see 2 holes. First, on the right is the mini drill hole. In the center of the picture, we have the full hole. The gray tailings tell us that there's something different about the inside of this rock than the surface of the rock. In the coming weeks, one of the things that we're trying to do with this first hole is to use this gray powder that we collect to clean the internal surfaces of the drill. We do that by moving the arm and swishing the powder around.
This was a great week for Curiosity. We got to see something we've been waiting for quite some time. Sample in the scoop confirming that our first drill on Mars collected as we had expected. This was an important event as this is the first time a drill has been used on Mars to collect sample for analysis by instruments on the rover. We use these computer-generated images of different volumes to help us visually identify how much we've collected. We were able to estimate that we collected about 14 cubic centimeters of sample, or about a tablespoon, and this matched our expectation of what we would see in the scoop when we got to this point. Our drilling capability gives us the ability to get inside this rock. The first thing you notice about the material is that it's a different color. Gray, not the reddish-orange color all around us. That reddish-orange color is a sign of an iron oxidation, a kind of rusting process that's occurred all around Mars. The next steps for the team are to finish processing this sample with Chimera and then put small portions into the SAM and CheMin instruments for analysis of chemistry and mineralogy.
This week, the Curiosity science team released its initial findings from its first ever drilled sample on Mars. This sample was collected from the John Klein drill site, which is located about 500 meters east of where we landed about 7 months ago. Curiosity obtained her first drill sample and passed that sample on to her onboard analytical instruments called CheMin and SAM. These powerful instruments tell us about what minerals are present in these rocks and whether they contain the ingredients necessary to sustain life as we know it. What the Curiosity team has found is incredibly exciting. When we combine what we've learned from our remote sensing and contact science instruments with the data that's coming in from CheMin and SAM, we get a picture of an ancient watery environment which would have been habitable had life been present in it. As an example, the information that we're getting from the CheMin instrument tells us that the minerals that are present in this lakebed sedimentary rock at John Klein are very different from just about anything we've ever analyzed before on Mars, and they tell us that the John Klein rock was deposited in a freshwater environment. This is an important contrast with other sedimentary environments that we've visited on Mars, like the Meridiani Planum landing site, where the Mars Exploration Rover Opportunity has been operating since 2004. At that site, sedimentary rocks record evidence of an environment that was only wet on a very intermittent basis. And when it was, the waters that were there were highly acidic, very salty, and not favorable for the survival of organic compounds. This is in direct contrast to the freshwater environment we're seeing here at the John Klein site. The SAM instrument is telling us that these rocks contained all the ingredients necessary for a habitable environment. We found carbon, sulfur, and oxygen, all present in a variety of states that life could have taken advantage of. All in all, these few tablespoons of powder from a Martian rock have provided the Curiosity science team with an exciting new data set that tells us that Gale Crater, and perhaps all of Mars, contained habitable environments. This is an incredible success for the Curiosity mission to Gale, and the science team is looking forward to digging deeper into Mars's ancient watery past in the weeks, months, and years ahead.